Chapter 2.6 is where we're starting, is with rational functions. And our learning target that we want to cover today is how to identify asymptotes, holes, and intercepts. So first we want to talk about what those types of things are. So if we have a vertical intercept, asymptote, we think about how we find those. How do we get a vertical asymptote in a rational function? Where does that appear? When the denominator of a fraction, you think of a denominator of a fraction, is equal to 0, that's undefined. We know that that doesn't exist, so that's not going to be anything that we graph. So that's how we get a vertical asymptote in a rational function. So to be able to calculate that value, so to find that, we set the denominator equal to 0. So we're going to set that denominator equal to 0 so we can find our vertical asymptotes. For horizontal asymptotes, we have three scenarios that can happen, and it's the way you find a horizontal asymptote is the relationship between the numerator and the denominator. So it's a comparison of the degree of the numerator and the denominator of a rational function. So you really have three scenarios that can happen for that comparison of the degree for those horizontal asymptotes. So let's take a look at those three scenarios that we could possibly have. So if I have a horizontal asymptote, let's think of any function as having a numerator that we'll call n of x and a denominator that we'll call d of x. And so this is going to represent the numerator and the denominator. So the first scenario that you could possibly have is that you can have this situation where the denominator has a bigger degree than the numerator. So if we have in the case 1, where we have the numerator degree, so this is going to be stand for the degree, and the degree. Not necessarily the function that is the numerator or the denominator, but the degree. So the numerator, we're going to say that that's smaller, and the denominator is bigger. So that's case 1. The numerator is smaller, so the degree, and so we can call that bottom heavy. We'll call that bottom heavy. Let's see, we have names for these. That's going to be bottom heavy. And if it's bottom heavy, then our horizontal asymptote, I'll write that with h-tote, is going to automatically be y equals 0. So there's no math involved. You already know that the horizontal asymptote is y equals 0. Case 2 that we could possibly have is that they're the same. We could have the degree of the numerator and the denominator be the same. So let's say bottom heavy, we have a numerator has a degree of 1, denominator has a degree of 2. That would be bottom heavy. Let's say they both have a degree of 1. So that's case 2. We have the numerator's degree is equal to the denominator's degree. And so we'll call that equal heavy. Really innovative with these names here. Equal heavy. And so what we look at there, if it's equal heavy, is the horizontal asymptote is the relationship of the leading coefficient. So it's going to be the leading coefficient of the numerator over the leading coefficient of the denominator. So our asymptote will be wherever that is. So let's say the coefficient of the numerator is 2, denominator is 1, then that value will just be y equals 2, because 2 over 1 reduces to 2. The third case that we could possibly have is we have the one where the numerator is smaller, then where they're equal, and then where the numerator is the biggest. So n of x is greater than d of x. So that degree is bigger on the top. And this looks like it can't see this. So numerator of is greater than the denominator's degree. And so in that case, we call that top heavy. Hopefully these are all making sense, whichever one's the biggest. So top heavy. And in that case, we actually have no horizontal asymptote. So no horizontal asymptote. We actually aren't going to get too deep into these. That would involve polynomial long division, which we are not going to cover. So if you are asked the question, you have a problem where the numerator is bigger than the denominator, you can just go ahead and say there's none. There's no horizontal asymptote for that. All right, so we're going to get into describing these values or finding these values, or some examples here. So the first example here we're going to cover is example 1, and we're going to find the 4 pieces of key information that we've talked about so far. So our example 1 here is going to be f of x is equal to negative x squared minus 2x plus 8 all over x squared minus 9. And so the first thing we want to find is that vertical asymptote. And the way that we solve the vertical asymptote, if you remember back from your notes already, is that vertical asymptote is by setting the denominator equal to 0. So when we do that, we'll set this denominator equal to 0, x squared minus 9 equal to 0. When we solve here, we'll add the 9 over, get x squared, whoa, that was a lot. So x squared is equal to 9, square root both sides, so x is equal to plus or minus 3. So that means we have 2 vertical asymptotes. We'll have one at positive 3 and negative 3. So if we want to solve for those, our vertical asymptote, x is equal to 3, x is equal to negative 3. Now we'll go ahead and look for our horizontal asymptote. Now our degree here is for our numerator is 2. Our degree for our denominator is also 2. So since they are the same, this is called equal heavy. So when we look at equal heavy, we look at the leading coefficient. Our leading coefficient here is negative 1. Our leading coefficient here is 1. So we have that relationship of negative 1 over 1. And that gives us y equals negative 1 when we reduce. The next thing we need to find are the solutions. So we've already found our vertical asymptote and our horizontal asymptote. We haven't really talked about the solutions yet. But the solutions are the same thing as zeros, are the same thing as x-intercepts. So it's where our graph crosses the x-axis. And so when you find solutions to our rational function, that's going to be, you find that by set the numerator equal to 0. So that's your numerator. So our numerator here was negative x squared minus 2x plus 8. So we are going to set that equal to 0 and solve. So we set that numerator, negative x squared minus 2x plus 8. We want to factor this. First I'm going to factor out the GCF, or that leading coefficient here. We want to make our lives easier. So x squared plus 2x minus 8 equals 0. And 2 factors of negative 8 that adding gives me 2 are going to be x, plus 4 and x minus 2. And so when I solve each of these factors, I'm going to solve the x plus 4 and the x minus 2. I don't care about that negative 1, because if I were to divide this whole thing by negative 1, I would just get 0 divided by negative 1, which is just 0. There's no x here to solve for. So we'll have x is equal to negative 4 and x is equal to 2. But these need to be written as ordered pairs. They are points. So x, wow. So we have negative 4, comma 0 and 2, comma 0. And these are our 2 solutions. We found our 2 solutions here. Our next example, we're going to take a look at the function f of x is equal to x squared minus x minus 2 over x squared minus x minus 6. Now I find it simpler to find our vertical asymptote, our horizontal asymptote, and our solutions if we go ahead and factor first. So we're going to do that here. 2 factors of negative 2 that add and give me negative 1 are negative 2 and positive 1. And then 2 factors of negative 6 that add and give me negative 1 are going to be negative 3 and positive 2. And so we see that nothing cancels. We'll get into that in a little bit. But we're able to find our vertical asymptote, or totes in this case, our horizontal asymptote, and our solutions after we've factored. So remember, our vertical asymptote is when we set the denominator equal to 0. That horizontal asymptote is the relationship or the comparison of the numerator versus the denominator. And our solution is going to be that numerator equal to 0. So, in looking at this problem, we have the denominator set equal to 0 will give us two vertical asymptotes, one at 3 and one at -2. So x equals 3 and x equals -2. Then we have our horizontal asymptote, that comparison of degree. We have a degree of 2 and 2. So this is equal heavy, meaning that we just look at the coefficients. So there's an imaginary 1 written in front of each of those. So 1 over 1 reduces to 1. And then our solutions are numerator. So if we set our numerator equal to 0, we get +2 and -1. So those are 2 points where we cross the x-axis at 2, 0 and -1, 0. Our next example that we're going to take a look at is going to be example 3 here. And we have f of x is equal to -3x plus 12 over x minus 3. So we're going to again look for our vertical asymptote, look for our horizontal asymptote, or totes, and our solutions. And I'd like you to take a look at these and see if you can find the vertical asymptote, horizontal asymptote, and solution on your own first. So when you did this, hopefully you came up with x is equal to 3 for that vertical asymptote, because that's your denominator set equal to 0. Our horizontal asymptote is always that relationship of the comparison here from our numerator and denominator. We have a degree of 1 for both of these. So we have -3 over 1, which is just y equals -3. And then our solution here is if we set the numerator equal to 0, or what I would like to do is actually factor this, factor out that -3 and get x minus 4 over x minus 3. And so we get a solution of 4, 0 for this one.